Good morning, everyone. I'm Zubair Hussain. I'm a senior environmental engineering student, and today we're going to discuss a 2013 case study by Carvalho et al., where enzyme responses in Apis mellifera were measured for exposure to three pesticides, deltamethrin, fipronil, and spinosad. Now, the Apis mellifera is more commonly known as the Western honeybee, and that's the little guy-gal non-binary pal you can see on the title slide here. So we've all heard about hashtag Save the Bees and how important honeybees are for the environment. And the good news is the study goes to show that these biomarkers could be a great indicator of the state of the environment and the health of the honeybees. And the reason that's important is because for us to begin solving a problem, to begin tackling a problem, we must first assess the problem and know how to quantify the problem properly. So the Apis mellifera, it's crucial for the environment, the economy, and for agriculture. The Western honeybee is an important pollinator, and they can stray up to 1.5 to 3 kilometers away from their hives in search of pollen, nectar, and water. And it's during these excursions that they might be exposed to contaminants such as pesticides, pyrethroid, deltamethrin, phenylpyrazole fipronil, spinosyn, spinosad are among the most commonly used insecticide types, especially in agriculture. And they work by blocking the voltage-dependent sodium channels, which leads to rapid depolarization of neurons, antagonizing gamma aminobutyric acid receptors, or GABARs, and acting as agonists of nicotinic acetylcholine receptors and antagonists of GABAR, respectively. So in short, the deltamethrins block sodium channels, the fipronils antagonize GABAR, and the spinosades are agonists of nicotinic acetylcholine and antagonists of GABAR. And the aggravated pesticide use contributes significantly to diminishing numbers of bees because these substances are very toxic to honeybees, especially those three. And they have LD50 values ranging from 4 nanograms per bee to 67 nanograms per bee, which, as you can tell, isn't super high. And yeah, they're definitely among the causes for the downward trend in their population. Now, not many studies using live bioindicators like this use honeybee enzymatic responses. And the first study to actually do so was done by Metcalf and March in 1949. And this study, the Carvalho et al. Study, also backs up previous research that demonstrates biomarkers as being useful tools for gauging the presence of pesticides in the environment. So how was this study conducted? Let's look at the methodology. Deltamethrin and fipronil were obtained from Sigma Aldrich. Spinosad was provided by the Clouseau Info Labo. The honeybees came from the Institut National de la Recherche Agronomique, INRA, from Avignon, France. And the honeybees were kept in plastic cages, with each cage containing 30 bees. And they were given a night's rest first. And then in the morning, from 8 to 10 a.m., they were administered mild carbon dioxide anesthetic and 1 microliter insecticide solution with proper dose to determine the LD50. Now, after they were administered this, a 24 to 48 hour waiting period ensued. And at the end of that, the bees were administered 1/20th and 1/10th, that's LD50-20 and LD50-10 doses of the pesticides. And the researchers waited another 48 hours. Now, after that, the bees that were still alive were separated and tissue samples were collected and frozen at -80 degrees Celsius to await biomarker testing. Insecticide concentrations were determined by gas chromatography tandem mass spectrometry. And to make sure the bees were not subjected to unnecessary pain, tissue samples were collected after giving the bees anesthesia. The samples were taken from the heads and midguts, and this was done at 4 degrees Celsius. The tissues were centrifuged at 13,000 Gs, and the supernatants were stored at the aforementioned -80 degrees Celsius. Continuing, the enzyme tests were conducted in a variant carry 1E UV vis spectrophotometer at 25 degrees Celsius. And the following enzymes and the responses were used as biomarkers. They were classed as either neural or metabolic biomarkers. So the neural biomarkers were acetylcholinesterase and carboxylesterases 1, 2, and 3. And the metabolic biomarkers were glutathione S transferase, catalase, and alkaline phosphatase. Now, fipronil had the lowest LD50 dose of 5.83 grams nanograms per B. And so fipronil correspondingly exhibited the highest acute toxicity for honeybees. Deltamethrin had an LD50 of 50.65 nanograms per B, and spinosad was at 47.11 nanograms per B. So deltamethrin induced a sort of lethargy in the honeybees, which subsided after about 1 to 2 hours for both the LD50-20 and the LD50-10 doses. The effects on the neural enzymes and metabolic enzymes were studied. Studies have shown that neural biomarkers are usually the most affected by pesticides, and spinosad was shown to decrease acetylcholinesterase function regardless of dose, while deltamethrin and fipronil did not seem to cause any change in the functions for the same biomarker. And no deaths were recorded for either the LD50-20 or the LD50-10 doses, which proves that they are non-lethal, below lethal doses. So the carboxylesterase responses were affected differently by all three pesticides. Regardless of dose, deltamethrin exposure resulted in increased carboxylesterase 2 activity, while carboxylesterase 1 activity decreased at the largest dose only. As for carboxylesterase 3, there were no significant changes in activity. Now, both LD50-20 and LD50-10 doses of fipronil and spinosad resulted in increased catalase activity. And the thing about these toxicity studies is that pesticide responses of bees changes by season and by colony. So it's important to establish controls by performing toxicity studies first, and that was obviously done here. So the fipronil LD50, which remember, fipronil was the most acutely toxic to the bees. The fipronil LD50 is in the same range as the values in Tingle et al. And Decortier et al. Studies. And the deltamethrin LD50 seems to be slightly lower than in other similar studies like the Atkins et al. Study, while for spinosad, it is within the expected range as established by existing research, such as Mays et al. So in conclusion, biomarkers are a biomarker is a change that can be quantified and perceived on the molecular, biochemical, cellular, physiological, or behavioral level, and which is brought about by a foreign chemical. And in this study, Carvalho et al. Studied enzymatic responses to pesticide exposure in the Apis mellifera. And Apis mellifera is a good subject because of its economic, agricultural, and environmental significance as a pollinator. So biomarkers and the responses can be used as auxiliary gauges for overall environmental conditions. And this study demonstrates that deltamethrin, fipronil, and spinosad are toxic to the Western honeybee. So even when they're exposed to below lethal doses such as the LD50-20 and the LD50-10, the honeybees exhibit abnormal changes in the activity of a collection of essential enzymes that are in charge of physiological functions. Now, these changes impair the health of the bees by weakening their cognition and ability to fight off pathogens and disease, thus decreasing their chances of surviving in the wild. The responses of these enzymes are quite specific to the type and dose of the pesticides, which means they're good and useful biomarkers. The study confirms the real-world value of using enzymatic responses of Apis mellifera, the Western honeybee, to detect the presence of pesticides in the environment. And that's about it from me. Thank you for listening. Here is Jerry Seinfeld as a bee.